you're watching the 2.5 lesson video notes of average rate of change. Average rate of change, average rate of change, average rate of change. What does it mean? Really, it's just slope. Slope, 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 slope. Instead, they want you to say it as average rate of change. Well, why? Why would they want you to do this? Well, because you can actually find the average rate of change over 2 points of any function, where we call a linear function slope because a line has the same average rate of change over the whole entire function. Let's see this in action. So exercise number 1. We have got to look at finding the average rate of change. Whoa, what's happening? Okay. Sorry, my computer was spazzing out. I think it's good now. So find the average rate of change of each of the functions below given each interval. So they gave you a bunch of intervals. So this is from -2 to 4. The intervals are the x values. So we're going to use that to help us. So when x is -2, that would be this point here. And when x is 1, 2, 3, 4, that would be that point there. So remember slope. Slope is rise over run, right? You like probably exhausted your brains with that last year. So up 1, 2, 3. So up 3. And then to the right, 1, 2, 3, 4, 5, 6. So rise over run is really simplified to 1/2. All right, let's do the same thing with b. Let me use a different color. Why did I use boring black? Okay, -2. So we're going to go -2 on the x value, but we have to look up to get our point. Oh, this line is sloping downward, so this number better be negative. Okay, +2. Here she is, or he is. All right, so if I go from the left point to the right point, I always go from left to right like I read a book. I have to go down 1, 2, 3, 4, 5, 6. So down 6 and to the right 1, 2, 3, 4, to the right 4. Down 6 to the right 4. Did I do that right? I just want to double check. 1, 2, 3, 4, 5, 6. Okay, cool. Simplifies to -3/2. Don't believe me? Type it in your calculator. Okay, now, important point to bring up. Wouldn't this be 1/2 between every single point on, let's say, A? So if I picked this point, up 1 to the right 2, 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 this is going to happen every single time that we have a line. But as soon as we get to, let's say, an absolute value function, which we see in C, that's not going to be the case because I could go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, but then over here I can go up 1 to the right 1, up 1 to the right 1. So it's not going to help me if I'm not given 2 specific points, okay? So from -1, so here we are, to 2. 1, 2. Okay, so there's my value of 2. There's my x value of -1. This line, this green line here is what we need to find the slope of. Oh my gosh, that was like the ugliest line I've ever drawn. Well, probably not ever, but let me make it a little straighter. Okay, so how do I get from the leftmost green point to the rightmost green point? Well, let's keep it Christmas colors, or let's use Christmas colors. I have to go down 1 to the right 1, 2, 3. So down 1 to the right 3 gives me a slope of -1/3. Okay, so we have to seek out those points because look at it. If I tried to find the average rate of change, I would have hit this weird little point at the bottom and that would have just been really, really crazy. And we don't want to do that. Ooh, are you guys dizzy yet? Sorry, I don't know why I keep doing that. Okay, I'll stop. All right, from -3 to 0. So -3, -1, -2, -3. I have to look up to get that cute point there. And 0 is right here. Oh, look at, we're slanting down again. We have, I drew another not straight line, but I'll deal with it. It's slanting down. Therefore, the average rate of change is going to be negative. I'll pick green. I have to go down 1, 2, 3. So down 3 to the right 1, 2, 3. If I went down 3 to the right 3 and divided those, I'd get -1. All right, moving on. To find the average rate of change, it's really finding the slope between 2 points. That's a big deal. If you have more than 2 points, you are doing something wrong. Okay, making a table is a really big deal. So let's look at some different examples here. So exercise 2 gives us a function. How do we know this function is not linear? Well, linear would mean the average rate of change has to be the same. So check it out. My x values are all going up by 1. So my y values better do the same. -1, no, I'm dropping what? 3, I'm dropping 5. This is definitely not linear because the y values do not go down at a constant rate. When the x values do. Okay, so what is the average rate of change over the interval from 2 to 4? From 2 to 4. We only need those 2 points. So x, actually, shouldn't I make this h of x? Yeah, I like that better. Okay, so x, h of x. Make a table. I'm just going to break it down. I'm copying and pasting the 0.29 and 41 to give me a better idea of what we're looking at. And then I'm just going to figure out how those points changed. How did I get from 2 to 4? How did I get from 9 to 1? Well, -8 going up 2. Remember, slope is y over x, right? Rise over run. So -8 divided by 2, my average rate of change is 4. All right, exercise 3, Frances, she's selling lemonade. It's a weird function. This is a quadratic function or a parabola. We'll talk more about that vocab later. But we're dealing with the model of glasses she's sold after T hours. What is the average rate at which she is selling lemonade? Okay, we wouldn't be able to do this unless they restricted the domain, and they did. We are happy from 2 to 6. If you want, make a table of 2 points, or we're given a graph. So I'm not even going to bother with that. I'm going to find 2 on my graph and 4 on my graph, and then just find the points that match up. So 2, 4, and 4, 10. Oh, I better be careful of my scale here. So I go up 2, 4, 6, and then over 1, 2. Okay, so my x values were just counting by 1s, but my y values were counting by 2s. So what is it? 6 over 2 is equal to 3. So what are we doing? We're modeling the number of glasses she sold after T hours. So 3 glasses per hour. We could have also modeled it as 6 glasses every 2 hours. All right, exercise 4. Here we go. We are given this function, okay, and we need to find the average rate of change between these 2 points. You know what? This is a perfect question for a calculator. Let's get the calculators out. Take yours out too. We'll have fun together using our calculators. All right, so we need to add a new document, and we're going to graph the function x squared plus 3. Hit enter to graph. There she is. Control T is going to show us our table. So we need the x value of -1, which I have highlighted right here. So my x value has to go from -1 to 3. So what's the point? -1, 4, and then let's find 3, 3, 12. Okay, now we have the table. This is so easy. How does 4 become 12? Yes, we add 8. How does -1 become 3? Yes, we have to add 4. So 8 over 4, rise over run is dose, 2. Here's the steps. If you need to use them again, you're going to probably need this for the practice. Okay, exercise 5. We're at 10 minutes. All right, hold on one second. Read this one. You know what? Read it. See if you can answer it. This is a bonus question for those of you. No, actually, I don't know if this is a bonus question. Hang on a second. Let me get my thoughts together. Okay, I totally lied to all of you. We're all going to do this question together. It is not a bonus question. I am sorry. I am sorry. I am sorry. Okay, we're given this awesome graph. It's really weird looking, but we need to find which one of these intervals has the slowest average rate of change. So we're looking for the smallest number. And oh my gosh, it's so cute. They gave us all of the intervals. So I am going to make 1, 2, 3, 4 tables. Oh, do you see how that magic just happened? Okay, so what did I do here? I just started finding the points. So I knew I needed the x values from 0 to 5. So 0 to 5. And those were my 2 points that I put in that table. I did that for every single one of the other answer choices. There's no quick way about this question. You got to do them all. So now what I'm going to do is I'm going to pause the video again and find out how all of these have changed. All right, so I went through and I calculated the average rate of change of every single one of those beautiful tables. We are looking for the slowest average rate of change. Sorry that I just had to pause the video. I can't remember what I said because I just had to answer a call, but okay. So we're looking at this. We have now found all of the average rates of change, and we want the slowest one, meaning we want the smallest change. The smallest number, it would be the absolute value of a number. Like right now, this negative 5.4 looks like a small number, but to me that's a really significant average rate of change compared to all of the other ones. It's just a big drop. We can deal with drops or increases, but we just want the smallest change over all those intervals. So which one is that going to be? We're looking for the number that's closest to 0 out of all of these, and that happens to be 0.2, which is answer choice 2.